Hey, I hope you had an amazing weekend this past weekend. I hope you guys got to watch the services on Sunday. And I encourage you, even though you're not able to go to church, make sure you're watching those videos, the live streams that they do. Or if you can't do it in the morning, go back and watch them. I think they're very important and very helpful. All right, let's go ahead and jump straight into our lesson. We're on lesson 88, and we'll be doing the entire lesson, not in one video. I'm going to split it up in two parts. We're going to do the first, the odd numbers of 1 through 15 here in part 1, along with the lesson, and then we'll do the rest of the problems in part 2. But yes, today on Monday, you have to do problems 1 through 30 for your math. All right, so let's jump right in. A number line can help us compare numbers, okay? So here we have a number line. It's set from -6 to +5. Looking at a number line, we see that the further and further we move to the left, okay? So if we start from the right, the further we move to the left, the smaller the numbers gets, all right? And then here we see, since -3 is to the left, we see -3, since -3 is to the left of 2, we know that -3 is less than -2. This is going to be important because we're going to start working with negative numbers, and you need to understand that the greater the negative number, the smaller it is, okay? So let's take -5 and -2, for example. Here we have our comparison circle, so we need to see which one is greater than, less than, or equal. Okay, so I've got my chalk here. So we need to determine which one is greater. Is -5 or -2 greater? Now, if we were just looking at the numbers, obviously 5 is greater than 2, but we're working with negative numbers. And so the bigger, the larger the negative number is, the smaller it actually is. It's less than. So in this case, -2 is greater than -5. We could see that here. We see how the 2 is closer to the 0 than the 5 is to the 0, or the 5 is further away from the 0. Okay, so the further away we move to the left in our number line, the smaller the number. Okay, so for this comparison, -2 is greater than 5. This is also going to be important when arranging numbers. And again, make sure you're following along in your books, page 422, lesson 88. We have a problem here to set up. Arrange the order from least to greatest. So we have 0, 2, 3, 1. Now, if we were just looking at the numbers, we would all obviously go like 0, 1, 2, 3. And then we'd go, that'd be from least to greatest. But we've got negative numbers here. So we've got to arrange them in the right order. Again, the smallest number, the number with the least worth, is going to be the number furthest away from the 0, okay? In this case, the -3. So we put our -3 first. That's the smallest number. The next smallest number would be -1, then obviously 0, and then +2 would be the greatest number. And so 0, 2, -3, -1, arranged in order from least to greatest would be -3, -1, 0, and 2. All right? All right, let's move on to page 423, square roots. If we know the area of a square, we can calculate the length of each side. This square has an area of 100 millimeters, okay? So we've got a square here. We've got a square here, and we know its area. And based on its area, we're gonna figure out what's the measurement of each side, okay? So the area is 100 millimeters squared. Okay, remember, to find the area, we multiply the length times the width. Okay, so our square has 4 equal sides. All right, so what two numbers multiplied together equal 100? Okay, so we see here, we know that each length of the side is, or would be, 10 millimeters. Okay, because 10 times 10 equals 100. Okay, they have to be equal. Now, again, and we've gone over this in class before, you can't do a number like, let's say 25 times 4, because those aren't equal lengths. They have, so when thinking of a square, think of equal sides. They have to be equal sides. So what number times itself equals the number we're looking for? In this case, it's 100. So we see that 10 times 10 equals 100. So by knowing the area of the square, we were able to find the length and width of the square. All right, let's move on. Calculating the length of the side of the square from the area of the square is a picture of a version of finding the square root. So we're moving into that field of looking for the square root of numbers. Finding the square root of the number is the opposite of squaring the number. So you guys are pretty familiar with this. We have 6 with an exponent of 2, or 6 squared, okay? That simply means this is a shortened version of 6 times 6. All right, remember, it's not 6 times 2, it's 6 times the number itself. So 6 times 6, if that number were 3, you'd be 6 times 6 times 6. But we've got 6 times 6 equals 36. Now, when they ask for the square root, they're going to use this symbol right here. So I've placed my symbol inside the square root symbol, and that is asking the question, what is the square root of 36? Okay, so the square root of 36 is 6. Let's move on here. They're going to do some more explaining. We read this expression right here as the square root of 100. So they're asking what number times itself equals this number. Okay, that's one way to look at it. And we already saw from the above example that that number would be 10. So the square root of 100 is 10. All right, we've got a couple more examples here. A number is a perfect square if it has a square root that is a whole number. The first 4 perfect squares are 1, 4, 9, and 6, and we'll see them here. All right, so we've got 1 squared. 1 times 1 equals 1. So if I put 1 inside this square root here, what is the square root of 1? It's 1, because 1 times 1 equals 1. Next, we have 2 squared. 2 squared equals 4. If I were to ask for the square root of 4, that would be 2, because 2 times 2 equals 4. Next, we have the square root of 3. 3 times 3 equals 9. So if I put it into the square root, what is the square root of 9? That would be 3, because 3 times 3 equals 9. And the same is true for 4. 4 squared equals 16. So if I place the 16 inside the square root symbol, what is the square root of 16? It's 4. Okay, so when you say 4 squared, the number is going to be greater. Okay, when we're squaring numbers, they get greater. When we're looking for the square root, they get smaller. There's a couple ways to think about that. Think about square roots. Roots go down, the numbers go lower, they're smaller. That might be a good way to remember it. You boys that sometimes get into arguments and you're like, square up. All right, so when you square a number, the number increases, it gets higher, okay? So that might be a couple of ways to remember. All right, again, same thing. I didn't get any responses for the practice answers for A and B from last week. So if you guys have the answers, if you have the answers to practice A, B, and C, go ahead and send those to me. I realize that the comments are disabled. You can send us a text. You can give me a call and give us those answers so that you could win the prize. All right, but let's move on. We're on problem number 1. What is the difference when the product of 1/2 and 1/2 is subtracted from the sum of 1/4 and 1/4? Now, when I set this problem up, I set it up wrong. And that's why it's important to pay attention. It's not set up wrong here, but before it was all written down, I had set it up wrong. But that's why it's important to read what the question is asking for. You see, I saw 1/2 and 1/2 first, and so I just put 1/2 times 1/2 first minus 1/4 plus 1/4. Now, if I would have done that, I wouldn't have been able to solve the problem because it was in the incorrect order because I didn't set it up the way the question asked for it. The question is asking what is the difference when the product, okay, is subtracted from the sum. Okay, so the order matters in the way that you set it up. But I set it up here correctly. We have the sum when they're asking for the sum, it's an addition problem. So we have 1/4 plus 1/4. Remember, when adding fractions, the denominators have to be the same. Thankfully, they are already the same for us. They both have the denominator of 4. And when we add fractions together, all we're adding or subtracting is the numerator. So 1 plus 1 is 2. So I've got 2/4. Next, the product of 1/2 times 1/2. When multiplying fractions, we multiply the numerator and the denominator. So 1 times 1 is 1. 2 times 2 is 2. So now I have 2/4 minus 1/4. Again, this is true for addition and subtraction. When adding and subtracting fractions, the denominators have to be the same okay? And when we go to add or subtract, it's only the numerators that are getting added or subtracted. In this case, we're subtracting we're subtracting 1 from 2, which equals 1, and our denominator remains the same. So the answer to number 1 is 1/4. Next, number 3. The recipe called for 3/4 cup of sugar. If the recipe is doubled, how much sugar should be used? So I simply set it up as 3/4 times 2. We're doubling it, okay? So now I've got 2/1 that represents my whole 2. And I could do a couple things. I could just multiply it and get 6/4, or I could cancel this out and get the final answer, which would be not final answer, but my improper fraction, 3/2. Now, my improper fraction is going to be changed into a mixed number. 2 goes into 3 one time evenly with 1 left over. So I write my remainder as a fraction. So the final answer would be 1 1/2. 1 1/2 would be the answer to problem number 3. 1 1/2 cups. All right, number 5. We are setting these in order: -2, 0, -4, and -6. And I believe we're going in order from least to greatest, okay? So remember, the number furthest to the left is the number that's gonna be the smallest. So if we go back here and look at our number line, the smallest number in our list would be -4. So I'd write -4. The next smallest number, we move to the right, or the next number on the list from least to greatest. So -2, okay, is less than -4 is less than -2. So that's the next number. And then our next one would be 0, and obviously 6 is our greatest number, 6 being the positive number on the number line. Okay, and so you see, if you work from least to greatest, you got 4, -4, -2, 0, and then 6. That's a really ugly 6. But anyway, all right, and that's how we set up our list from order from least to greatest. Next, number 7 is over here. What is the area of the triangle? Remember, our formula for finding the area is A equals base times height divided by 2. Several of you got that wrong on the test. Pay attention. All right, for a triangle is area equals base times height divided by 2. For a parallelogram, which we'll get to later, it's simply area equals base times height. But when we're dealing with a triangle, you gotta make sure you divide by 2 at the end, all right? So we've got our base of 8 inches, we've got our height of 5 inches, and a side that is 6 inches, okay? Now, for this particular problem, we're not gonna pay attention to the 6. We're gonna look at our height, which creates a perpendicular line with the base. Also something some of you guys got wrong on the test. The perpendicular line creates a right angle. That's an angle of 90 degrees with the base, okay? A perfect corner. So our height is 5 inches, our base is 8 inches. We multiply that, 8 inches times 5 inches. Also very important, make sure you put your units in there because those are getting multiplied as well. So 8 times 5 we know is 40, but we're also multiplying the inches. I gotta cut into the space a little. So it's inches squared. That's a little sloppy. And now you divide. So 2 goes into 40 20 times, and our units of measurements remain the same, inches squared. Okay? Very important that you write inches squared when working with our area. So the final answer to number 7 is 20 inches squared. Next, number 9. What is the perimeter of the parallelogram? Yes. All right, so here we're given the base, we're given the length of one of the sides. So 8 inches, 6 inches, and then the height is 5 inches. Now we do have to pay attention to the length of this side. So this side is parallel to this side, 6 inches, and this side is parallel to this side, 8 inches, okay? So now to find the perimeter, we simply find the sum of these 4 measurements. So 8 plus, let's do 8 plus 8 is 16, and 6 plus 6 is 12. So we've got 16 plus 12, which give us 28 inches. Now, would it be 28 inches squared? Okay, that's only when we multiply. So 28 inches squared is the perimeter of this particular parallelogram. Okay, next, number 11. We've got 3 1/4 minus 0.5, and the answer has to be in fraction form. So my decimal number needs to be changed into a fraction. Now, how do I do that? Well, I look at the number. I've got 5, and the 5 is in the tenths place, so that determines my denominator. My numerator will be the number that's given, the 5, and my denominator is based on the place value of the decimal. So I got a 0 in the ones place, a 5 in the tenths place. So that's how I determine my denominator, tenths place. If it was 0, 5, the 5 would be in the hundredths place, so my denominator would be 100. Anyway, we've got 5 tenths. So now I can subtract those. I've got 3 1/4 minus 5 tenths. Draw this line here, okay? Now, when dealing with fractions, it's very important that our denominators are the same. In this case, they're not. We've got 4 and 10. So we need to find the least common multiple between 4 and 10. The least common multiple between 4 and 10 is 20, okay? So in order to get both of my denominators to equal 20, I need to multiply the 10 by 2, and whatever I do to the denominator, I have to do to the numerator. So 10 times 2 is 20, and 5 times 2 is 10. So I've got this all set up. Now, to make my denominator 4 into a 20, I need to multiply it by 5. 4 times 5 is 20, 1 times 5, okay, because remember, whatever I do to the denominator, I have to do to the numerator. So 1 times 5 is 5. And I've got my whole number transferred over here. Now I can subtract it. I've got 3 and 5 over 20 minus 10 over 20. Now, I can't subtract 10 from 5, so I have to borrow from the 3. I have to borrow a whole from the 3. And the whole that we borrow is going to be determined by the denominator. Okay, so my whole is going to be represented by 20 over 20. And now I can add these. So remember, the denominators aren't added, only the numerators. So now I've got 25 over 20. So let's write that over here. 25 over 20 minus 10. 10 minus 25 is 15 over 20. And then I've my reduced 3. I've got 2 now. So 2 and 15 over 20. Now I've got to reduce this, okay? So which number goes evenly into both 15 and 20? The greatest number that goes into them evenly is 5. So I divide 5 by 15 divided by 5 is 3, and 20 divided by 5 is 4. Okay, so that gives me my final answer, my final reduced answer. Now, 2 and 15 over 20 is part way right, but not all the way right. In a test, this would maybe give you partial credit, but all your answers need to be reduced to final form. Next, 2 more problems. We've got 2 times 15 plus 2 plus 12. Okay, if you weren't paying attention for the last couple lessons, you would probably do something like this. 2 times 15 is 30, plus 2 is 32, so 32 times 12 would be whatever. But that would be the incorrect way of doing it, because we learned several lessons ago that there's an order in which we have to go. If there's no parentheses in the problem, the first operations we need to do are multiplication and division, and then from left to right, and then after that we do addition and subtraction. So first, let's do our multiplication. 2 times 15 is 30, okay? And then we do 2 times 12 is 24. Now we can add 30 plus 24 equals 54. So your final answer to this problem should be 54. Going in the incorrect order, or not following the standard order of operations, will give you an incorrect answer. Okay, so that's why it's very important first to do your multiplication, okay, from left to right, from, I don't know what's your left on the video, from left to right, and then doing your addition and subtraction from left to right. All right, final one for this part. Problem number 15, we've got $6 divided by 8, okay? So we know the $6 is going to be the dividend, okay? So I place it in the box. My 8 is the divisor, so I need to see if I can divide 6 by 8. 8 does not go into 6, so I write my 0. I line up my decimals in the quotient and the dividend. And next I see, how many times does 8 go into 60? Well, it goes into it 56 times evenly, so 7 times 8 is 56, we subtract it. Okay, we borrow from that becomes 5, that becomes a 10, 10 minus 6 is 4. So now I bring down the 0, let me write this little arrow so you can see. And now I see what number goes, or how many times does 8 go into 40 evenly? It's 5 times. 5 times 8 is 40. 40 minus 40 is 0. So my final answer here is 0.75. $6 divided by 8 is, might be a little crooked because I'm sideways. There it is, 0.75 cents. Okay, make sure that as you watch these videos, I know that I go pretty quickly through them, but again, you can pause them at any time. And if you need to look at the board to see how to set up your problem, go ahead and do that. But you do need to be showing your work and you need to be turning in that work. It's very important that you do that, okay? If you have any questions, give me a call. I'll see you in the next video.